Hello, everybody. You are all very, very welcome. My name is Dr. Kieran O'Cahan, and I am the course coordinator for Sports Science with Exercise Physiology in Athlone Institute of Technology. I'm delighted to be here to be able to give you guys an overview of our degree in Sports Science with Exercise Physiology, and hopefully it answers a number of the questions or queries you might have related to our course. So as you can imagine, the first question that we typically get about the degree is what are the entry requirements? How do I get into sports science? So you can see here that our entry requirements, we require a minimum grade of H5 at higher level in 2 subjects, plus a minimum grade of 06 or H7 at ordinary level in 4 other subjects in your leaving cert. Within that, 2 of these 6 subjects must be mathematics and a language, and that language can be either English or Irish, so it doesn't have to be a foreign language. Within that then, you can see that the points in 2020 were 351, but that does vary a little bit from year to year. So you've decided you want to do sports science, you've met the entry requirements. What is it that you're going to be studying and what does it look like? So if we give, I guess, a basic overview of the degree program initially, we can see that we have kind of a broad division of 5 strands, and we cover these 5 strands across the 4-year degree. Physiology and biomechanics being 2 of the very core subjects that you will complete modules in almost every year. We have psychology, nutrition, applied sports science skills, and professional skills. So when we talk about applied sports science skills and professional skills, these aren't specific modules, but we have modules tailored to address the needs of an applied sports scientist, a module to develop the professional skills that you are required to develop, again, to be a sports scientist. So we're going to give you an overview of each of these core areas in a little bit of detail, and I guess how many modules and when you'll be studying each of them across your 4-year degree. First of all, if we talk about physiology here, we're trying to understand how the human body functions. From biomechanics perspective, we're looking at human movement and trying to understand what drives human movement. How can we change human movement? Psychology, we're trying to get an indication of the mental side of exercise and sports performance. So what drives people to exercise? What drives people to perform at a high level? How does your mental capacity and your psychology influence that? Nutrition, we're obviously looking at, from a detailed perspective, how the food we eat influences our health, but also how it can optimize our performance in a sporting setting. And within each of these, we very much, and across the whole degree, we have a broader division where we can look at these 5 strands within the context of sports science to improve sporting performance. But this is also an exercise physiology degree, so sports science with exercise physiology. So we also look at the clinical side of this. So how does exercise improve health and function on a day-to-day basis and potentially prevent disease? So I guess a good place to start in terms of a more in-depth look is at our physiology modules. You can see here we have a number of specific physiology modules. So starting in first year, you'll have physiology in first and second semester, and this pattern will continue across the 4-year degree, where we'll have human physiology, applied human physiology, sport and exercise physiology. Again, you'll notice we're starting at the more basic end of covering all physiology, slowly moving toward the more specifics of the physiology and a more in-depth look of exercise physiology and what's important from a sporting perspective. We have modules like anatomy for sports science, when again, obviously we're looking at the human body, trying to understand all the different structures within that. And how does that influence our physiology, or why do we need to understand that so that we can make improvements to an athlete's physiology to either improve their health or to improve their capacity to perform? In 4th year, you'll move on to more applied modules, things like physiology for the high performance athlete, where it's really a deep dive into understanding elite level athletes, those high performers. What are the physiological aspects that drive performance across a multitude of different sports, and how can we train them? And again, and looking at things like assessing those athletes in a very detailed way. Another applied module in 4th year and is strength and conditioning. So a slightly different approach to physiology for the high performance athletes here, we're specifically looking at the development of capacities like strength, capacities like repeated sprint ability. So if we're looking at a Gaelic football, for example, how can we train their ability to continuously move at high speed with short amounts of recovery in a game? Strength and conditioning coach is obviously very much associated with being in the gym. So this module includes a lot of that type of work. So how do we train athletes to meet each of their individual goals within that setting? So very, very applied modules. And again, with strength and conditioning, it's very much underpinned by our understanding of human physiology, which you will have covered in prior years, as well as things like biomechanics, which we'll get to in a slide or two. So again, remember, I'm a strength and conditioning coach. I need to understand how the human body functions so that I can understand how it responds to exercise and subsequently how our physiology improves. And as a strength and conditioning coach, I need to understand biomechanics. So how do athletes move and how can I improve their movement? Whether that's to improve performance on the pitch or potentially to reduce injury occurrence. Finally, then we have modules in clinical populations where we're trying to get an understanding from a clinical perspective of what are the associations between exercise and our health. What things like physical inactivity we know are linked to our health status. So can we look at exercise interventions to improve the health status of our population and of individuals? And can we look at exercise as a rehabilitation method for people that potentially have suffered from cardiovascular disease, things like diabetes? And how can exercise and nutrition interventions help with those prognoses? So physiology covers a broad span, and it kind of underpins a number of different modules throughout the 4-year degree. From there, two of the other key modules that we cover, or key topic areas that we cover throughout the 4 years, are nutrition and psychology. So if we look at nutrition, modules that are directly linked to nutrition would be chemistry and cell biology. We then have a specific sports nutrition module in 2nd year, and then a more advanced sports nutrition module in 4th year. Now you'll see we've got two of the basic sciences there in chemistry and cell biology being linked to nutrition. And one of the things that I guess students question initially once they start sports science is, why do I need to do these basic sciences, chemistry, cell biology? What do these have to do with sport? Again, it's something that people don't think of once they're entering into sports science degree. And the truth is that chemistry and cell biology underpin a huge amount of understanding of nutrition, but also our understanding of physiology, linking back to the previous slide. So when I'm talking about sports nutrition, I need to understand the biochemistry of, once I eat a type of food, what happens to that food? Once I digest it, how do I take the nutrients from it? And how do I subsequently use them? That's all linked to chemistry and biochemistry. So here again, with sports nutrition and advanced sports nutrition, we're looking at strategies to optimize athlete performance, and how that changes across a year, in terms of if we're looking at an athlete that's in a competition period versus an athlete that's in a training period, and across different types of sporting disciplines where you're potentially working with, or looking at examples where you're working with athletes that are trying to build muscle, athletes that are trying to lose body fat, athletes that are trying to meet certain weight criteria for their performances. So it's very applied module and covers a broad number of disciplines within sport. In terms of psychology, again, you can see there's 3 key psychology modules across the 4-year degree. We have Intro to Sport and Exercise Psychology, Progressing to Sport and Exercise Psychology, and Advanced Psychology in Sport and Exercise. And again, these very much progress from one to the other. If we talk about the importance of psychology then as a sports scientist, linking back to nutrition, which is just above it there, it's all very well and good if we tell an athlete, this is what you need to eat to optimize your performance, but it's not often as easy as that. There's a psychological element in terms of how do you actually initiate some type of behavior change? You have to understand the psychology of the athlete to bring about those changes. Similar, if we're looking at general population, we know nutrition is directly linked to health in a lot of ways. How do we begin to change people's habits, their eating habits and their attitudes towards exercise potentially, so that they're more in line with what is going to benefit them from a health perspective? Someone that's been physically inactive for a long time, how do we get an understanding of that person and slowly begin to change their habits and behaviors so that they can start to become more physically active? This is all embedded in psychology. Similarly, how do we, if we do a deep dive in terms of the psychological elements of sporting performance, what is different about the highest performers from a psychological perspective that allows them to perform in very, very high stress situations relative to other athletes that potentially don't have that capacity, and what can we learn from that? So you'll see each of these different sub-disciplines very much interlink and influence each other. So it's extremely important as a sports scientist to have a good understanding of all these different areas, because as you can hopefully see, they all influence each other quite a bit. Biomechanics then, this is actually the area where I did my PhD. I also do a lot of work in nutrition now. So this is an area I'm particularly interested in. So you'll have, again, we see a number of biomechanics modules across the 4-year degree. It's one of our core areas, starting with introduction to biomechanics in first year, leading into a module on kinesiology, biomechanics and motor control in second year. And then we have an advanced biomechanics module in fourth year and a sports injuries module. So again, when we're talking about biomechanics, we're trying to get an understanding of human movement. And again, with this, we largely have two broad divisions. We have understanding movement related to the development of musculoskeletal disorders or injuries, and how do we subsequently change movement so that we don't predispose ourselves to injuries, or from a performance perspective, how does movement influence our performance on the pitch? Or if you're a sprinter, for example, how does the way I move influence how fast I can run 100 meters? And how can I subsequently make changes to my movement to improve my performance? So again, that encompasses a broad variety of different sub-disciplines and contexts within that. If we think back to physiology, again, we can see how biomechanics links back to our physiology. If we're talking about running here and we're potentially looking to change someone's running mechanics so that it improves or reduces their risk of injury, say, let's say we're looking at biomechanics, we're going to change their running style because we want to reduce risk of running injury. We also, in that context, have to understand how that potentially influences a runner's physiology, okay? So yes, we're changing their running style. It's going to result in a decreased risk in developing an injury, which is a positive. But what happens if all of a sudden that running style is much harder for the athlete to be able to run that way? It's going to cost a lot more energy. You can see that we need to be able to consider each side of the coin, and all these different disciplines suddenly start to integrate, and we have to have a good understanding of them. Equally, if we're now running in this different way, where it's got a higher energy cost, do I now need to consider the nutrition element? So do I need to start feeding people with more food because they're running in a way that is more energy costly? So again, a good example of how all these sub-disciplines are extremely important to a sports scientist in practice. From there, then we have a number of modules that really focus on the applied sports science skills. So it starts in first year and continues throughout the 4-year period. So one of your first modules in your first semester is fundamentals of sports science. And really the idea of this module is to embed you straight away into the concept of being a sports scientist. So you'll do a lot of practical work where you're testing athletes and testing, for the most part, you'll be working with each other, and you will get an opportunity then to test some athletes and teams towards the end of the semester. But looking at people's running ability, looking at people's jumping ability, looking at all the different components of fitness that influence performance. So it's very much an introduction to the concept of sports science. That will progress to things like introduction to coaching, applied coaching sciences. So yes, we obviously understand that the term coaching means different things in different contexts. You could have a strength and conditioning coach, you could have a fitness coach, you could have an endurance coach, depending on the scenario. But what is the science behind coaching practice? How do we get the best out of our athletes as coaches? And that's very much what you'll be covering in those modules. We have modules like performance analysis, which is largely focused on using video analysis and things like team sports to try and understand tactics and what's the best approach to manipulating things like team tactics to ensure performance, or to ensure or to put your team in the best possible situation to win if you're working with a team in that scenario. Performance testing in sport and exercise science is a second year module. Here, we're looking more at an individual level. What are the different components that relate to performance? How do you measure them so that once you apply a training program, you can actually assess if the training program is working over time? And then finally, another very applied module would be rehab and return to competition, where here you're looking at, okay, we've had one of our athletes that you work with, if you're a sports scientist, has developed some type of injury, okay? It's ruled them out of training, it's ruled them out of competition. They've went to their physiotherapist or their athletics therapist, they've done the initial stages of rehabilitation, they're ready to fully return to training. This is where the sports scientist potentially comes in, and working alongside the therapist will help the athlete get back to full fitness so that they can return to sport. And this focuses on that very practical element within that. Other professional skills that are developed across the 4-year program or modules that develop these skills are things like maths for sport and health. Again, sports science students come in every year and they're like, why am I studying mathematics? But it's extremely important for a number of different areas. First and foremost, we talked about biomechanics. The measurement of biomechanics very much is based in mathematics and physics. So we need a good understanding of maths for that. If we look at things like statistical analysis and data analysis, it all is based in mathematics. So if we want to be able to analyze a team's performance, we need to understand these mathematical principles. If we want to do research in sports science, we have to come up with methods to test research questions, and this is based on statistics. So again, it comes back to good understanding of mathematics. Marketing then and applied entrepreneurship, again, a very applied module. As a sports scientist, there's multiple different avenues that you can go once you finish this degree, and it's very much dependent on your own interests. A lot of the time we see people potentially building their own avenues or potentially building their own business or becoming self-employed. So obviously it's important to have a capacity to market yourself, to look at things like business development. And I guess the idea of this module is to provide you with some of those skills. Evidence-based learning and research methods, a huge part of being a sports scientist or a practitioner is being able to stay up to date with the current research. So that from two perspectives, so you know what's happening in the research, what are the developments that are potentially coming up that can inform practice, but also right now, what is the best practice? This comes from the literature. And I guess one of the reasons why we have to be so conscious of research, especially in sports science, is that it's a very, very young discipline. So things like textbooks can become outdated very quickly. So we have to look towards scientific literature to stay up to date. And these modules the goal of these modules, is to equip you with the skills to be able to break down research and subsequently put that into practice. Finally, in your final year, you'll do a final year research project. This is really a deep dive into a specific area of interest, where you can develop very, very specific expertise in this area, but also going through the process of completing a research project gives you a good understanding of scientific principles. And it's usually one of the modules or the projects that people enjoy the most in their 4-year degree. So that's kind of a broad overview of the different modules on the sports science degree. Something to take note of is that all of our modules will have a lab or a practical component associated with it, for the most part. So if you have 2 hours of lectures each week for a module, you typically also have 2 hours of practicals. Again, they'll be lab-based or field-based depending on the module. So something like performance testing, for example, a lot of your labs will be based in a sports science lab. Here in the background, we can see an example of a VO2 max test where we're assessing how much oxygen a person can consume and deliver to the muscle to provide energy. But because we know that's related to fitness, we know it's related to health, and we know it's related to things like endurance performance. If you don't have practical labs, instead of having your 2 hours labs, you might potentially have a 2-hour tutorial in modules that are more based in theory. um, alongside potentially another 1 hour of lab or practical based work. Again, this is something that as students enjoy a huge amount. We put the time for each module to cover the theory, but each week you as a student or the budding sports scientist get the opportunity to put this knowledge into practice straight away in a very practical setting. In third year then, our sports science students have the opportunity to go on a 24-week placement where they complete a minimum of 20 hours per week. And again, it's part of the degree that students really enjoy and they really engage with and come back with a huge amount of experience from. We rarely, or I don't think we've ever had a student having a bad experience with this part of the degree. In terms of opportunities, you can see here we've had opportunities with Sport Ireland, with the GA and the LGFA, but they vary a huge amount in terms of where people go on these placements, and it's very much dictated by the student's interest at the time. So we've kind of already touched on the idea that sports science is very multidisciplinary, and as a result, our work placement covers a lot of disciplines. So we have some people that go down the route of strength and conditioning, for example. They get a placement. We've had students with Connacht Rugby, with rugby teams in New Zealand and Australia. Some people are very interested in nutrition. They end up working for the placement in the area of nutrition. Some people are more interested in the clinical side of exercise physiology. One of our biggest placements every year is in MedX, where students are getting experience working with clinical populations and how exercise can be used to rehabilitate those clinical issues. So yeah, a broad variety, and again, a great opportunity that runs in semester 2 in year 3 from January to about August. As we progress throughout the degree then, we have a number of applied projects where you're really getting the opportunity to take all the theory that you've learned and put it into practice. Our research project, or our final year project, which we've discussed already, is a big one, but we have modules like advanced biomechanics in year 4, where you'll be working in the biomechanics lab, collecting data on athletes and trying to understand their movement, and make recommendations based on what the data you've collected. Similarly for physiology and strength conditioning. Strength and conditioning, for example, in 4th year, your assessment is all based on working with an athlete. So you will get an athlete, you'll be working with them on a week-to-week basis throughout the semester. And the goal of the module is to then design an annual training program for that athlete. You'll be assessed then on the science that underpins that program, but also on your capacity to deliver that program. So each week, as I said, the athletes that you're working with will come into the high performance gym, and you'll be graded on how you're interacting with the athletes, how you're coaching them through different sessions, and so on. So yeah, we really put a large emphasis on research and very applied projects throughout the degree program. Another big question that we get all the time is, okay, I've qualified as a sports scientist. What kind of careers can I pursue? And we can see a number of different careers here on the right-hand side there, but it very much varies depending on what your interests are. So we have people that go into testing and monitoring elite athletes as potentially physiologists, with people that end up working as a performance analysis in professional setups. So whether that's soccer or Gaelic football, whether it's rugby, where again, you're working on video analysis, you're looking at team tactics, trying to find weaknesses in oppositions, weaknesses in your own team, so you can obviously plug those gaps and so on. People then end up going down the route of coach education, so working with coaches to improve their skills as coaches, working in the area of strength and conditioning. A lot of people then also go down the clinical route, so where they're working in clinical exercise physiology or clinical rehabilitation programs. And a lot of people then end up potentially going down to do further study in a multitude of different areas, whether that's research-based or more applied masters in things like strength conditioning, nutrition, physiology. We've had people go on to become physiotherapists and so on. We've kind of alluded to already that sports science is very much embedded in research. And as a result, we also have a lot of people that go on to pursue research masters or PhDs. Again, in any of the different areas or sub-disciplines of sports science that we've discussed. So that could be a PhD in sports psychology, a PhD in exercise physiology, a PhD in biomechanics, a PhD in sports nutrition. and so on and so forth. So lots of different opportunities, and it's one of the great things about doing a sports science degree is that you're not put into a box straight away. This is what your job is, I guess, because it's such a broad and varied discipline. There's opportunity to move in multiple different directions. So lots of different opportunities. In terms of a department then, so sports science with exercise physiology degrees in the Department of Sport and Health Sciences. Obviously, I'm in this department, so I'm biased, but we have a great team of lecturers. Everyone's very engaged. And really, I guess the main thing here is it's very much a team environment. We're all very motivated in terms of teaching and research and trying to bring those two together, as well as practice. On the team, we have a lot of people that still are very involved in practice, whether that's in psychology or physiology, and bringing that experience in to deliver on the modules. So it's a young team as well, and it's very, very dynamic. And we have an amazing head of department in Dr. Aoife Lane, who is driving us forward, and the department is improving all the time. In terms of staff expertise, our full-time staff are all qualified to doctoral level, or else they're very, very reputable practitioners. Most of us are still very research active and or engaged with community and industry. So again, all very, very, very qualified and all very, very capable of delivering the very applied nature of the degree that we're trying to promote. On campus then as well, we've actually started this new research group called the She Research Group. And the goal of this research group, it's very, very exciting, is to focus on bridging the gender data gap in sports science. So we know a huge amount of sports science research very much focuses on males, so understanding male physiology with regard to sprint performance, like we see in the back here, or the biomechanics. And the female side of things is neglected quite a lot. So the goal with this research group is to very much bridge that gender data gap, start doing lots of research on female athletes. And in this already, we have 15 PhD students signed up to She-based projects. And it's something that we're very, very excited to progress in the coming years and hopefully get as many of you budding sports scientists as we can involved. Big question then is always about the facilities. So you can see here, we've got a beautiful campus and we have access to state-of-the-art both teaching and learning facilities. We have our sports science lab, which is equipped with all the necessary pieces of equipment that we need. So things like metabolic systems for measuring oxygen consumption, biomechanics lab. We're actually the first IT to have a motion capture system, so a Vicon motion capture system, which is the gold standard for measuring human movement. Again, something I'm very, very proud of. It's relatively new. In the last 2 to 3 years, we worked very hard to try and pull together and get this system. And we have our health science lab. We have our therapy rooms for our athletic therapy students, but also our athletic therapy students who are focused on sports injuries. Also provide a clinic then for anyone on campus that potentially has injuries. Also, typically a lot of our sports science students are involved in sport or exercise some capacity. So if they have any type of injury, there's the ART clinics that they can go to and get some advice on that. We have our high performance gym, fully equipped gym to a professional standard. Then also we have our international arena where we have an IAAF standard indoor athletics track and an outdoor athletics track. Every year we have a large indoor international athletics meet also. So excellent facilities. And then before I let you go, you've heard a lot about me professing how much I love the degree, but I'm sure you think my opinion is definitely biased because I love teaching on the degree and I love being part of it. But here is one of our former students giving some information about the course. Great, that's it from today's presentation. Hopefully I'll see a lot of you that have watched this at the AIT Open Day where I can answer more questions about the degree. Have a great day.